Transportation Seminar at Portland State University. My name is Chris Monsieur. I'm an associate chair in the associate professor and associate chair in the Civil and Environmental Engineering Department. Together with my colleagues, we co-organized this Friday Transportation Seminar I have been doing for quite some time. We're very pleased today to have one of our own students giving the presentation today. So Patrick Singleton is a second-year master's student in the Civil and Environmental Engineering Department. He's working with Kelly Clifton, Professor Kelly Clifton, completing his thesis. He's originally from Portland. He got his bachelor's degree at the University of Pittsburgh and then worked some time in Pittsburgh before returning here to come back for his master's degree. He's applied to the PhD program. We're very excited about that. And he's here to talk today about pedestrians and regional travel demand models, state of the practice, a presentation and poster he gave at the Transportation Research Board 2 weeks ago now. So thanks, Patrick.
Well, thank you very much, and thanks for coming, everyone. Again, I'm Patrick Singleton, and I'll be telling you about a project that I worked on with my advisor, Dr. Kelly Clifton, dealing with pedestrians in regional travel demand forecasting models. So before we get into details, I just want to go a little bit over what some of the different ways we can plan for pedestrians, specifically estimate pedestrian demand. But before I do that, actually, let's talk about what we're going to cover in this lecture. I'll give you a little bit background about the modeling process, talk about the methods that we used in this study, discuss some of the frameworks that we classified these models into, talk about some operational issues we found, discuss the results of a survey we conducted, and then finally conclude with some closing thoughts for the future. So again, there are quite a few different ways that we can estimate the demand for walking. There are sketch planning tools that may use general rules of thumb to get a basic rough estimate. There are more detailed site or facility-specific tools that can directly predict the demand at maybe certain intersections, pedestrian crossing volumes, or maybe on trails, predict the volume of pedestrians walking along off-street trails. In addition, there are some interesting network-based models, things like space syntax, producing the network of streets to predict that, as well as some GIS-based tools that use networks or rasters to sort of get an aggregate or aggregate level of activity or possible pedestrian activity. But what I'll be talking about today are regional travel demand forecasting models. These are the ones that metropolitan planning organizations use to run their forecasting tools to predict, future travel demand for all modes of transportation, plan for investment in future transportation projects. So one reason why these MPOs may be interested in making their models more sophisticated and better able to predict pedestrian demand is, one, they're looking for trying to model the interconnectedness of activities, travel, and land use. Two, they may be interested in evaluating the effectiveness of pedestrian-related investments, projects like sidewalk construction or maybe a mixed-use development. They also want to know maybe some of the effects of policy interventions or economic changes can have on pedestrian demand, but also other kinds of outputs, how many people might shift to walking or other modes. So just to give you a quick example of some of the ways that MPOs might use these models, here in Portland in the 1990s, there was the LUTRAC project, making the land use, transportation, and air quality connection, which started as a sort of an opposition to a proposed freeway along the west side of the Portland area. And it eventually led to modeling changes in the region, including the ability for Metro's model to forecast transit and pedestrian-focused alternatives. More recently, in Sacramento and San Diego, agencies there have used their models to, predict smart growth strategies or scenarios for the future, including making their models more sensitive to land use changes, 4D effects about the built environment, density of people and jobs, diversity of land uses, destinations, and design of the street network or urban form. So let's get a little history about how these models have developed so we could have a better understanding of what we see today in the practice. So the basic format of how these models operate, which I'll go into in just a sec, was established back in the 50s and 60s typically, and regions were interested in forecasting the demand for automobile use. So those models pretty much reflected only travel by automobile. In the 60s and 70s, they became more sensitive to transit uses, but it wasn't until the late 1880s that we actually saw the first inclusion of non-motorized travel into this same framework. Here in Portland, Metro was the first to do that in 1988. At about the same time, in the suburbs of DC in southern Maryland, an agency actually incorporated some non-motorized specific variables into their model to try to get at some of the land use and environmental impacts of on travel by walking and biking, things like bicycle facilities, bike lanes, or maybe sidewalks. Into the 1990s, the LUTRAC project again, one of the outcomes of that project was the development of a pedestrian environment factor, which contributed into the modeling steps, and it was sort of an index of the ease of street crossings, sidewalk continuity, gridness, and a measure of terrain. So in the last 20 to 25 years, we've seen a big change in modeling practice, and so our study identified actually that 63% of large MPOs actually include non-motorized modes in their model, as opposed to the one back in 1988. Just to make sure that we're all on the same page, I know most of you probably are familiar with the travel demand modeling process, but for those who aren't, I just want to go over this really briefly. You'll see here the typical 4 steps of a trip-based travel demand model. There's trip generation, how many trips start here? Say 100 trips start in this building. And then there's trip distribution. Where do those trips go? Let's say 25 of them head over to Waterfront Park. Next is mode choice, whether people walk, whether they're going to drive, whether they'll take transit, whether they'll ride a skateboard or a Segway. And then finally, assignment. What route or path through the network will they take? Maybe they could go via First and Main. That might be the most efficient for them. And so in the next steps, when I talk about the frameworks, I'll try to classify the models based on how those 4 steps of the model represent pedestrians. So now I'd like to talk to you a little bit about what the methodology and the goals we had for this project. So first off, the basis for this was a project that we're currently underway, working with Metro on how to change their travel demand forecasting model to better represent pedestrians. And so we wanted to identify what the state of the practice was, what some of the frameworks and models and variables that are used, what may be some changes in future evolution of modeling practice, and what may be some barriers to making more sophisticated models. We also wanted to provide guidance not just to Metro, but to other MPOs who may be interested in making some of these modeling changes, and give them some options for their different needs and resources. So to do this, we looked at the 48 largest MPOs in the country, those that serve over 1 million people. We looked at their model documentation, and then we conducted a survey of their lead modelers, asking them some questions. I want to note that we only looked at full walk trips. We didn't look at walking to access another mode like transit. The reason for that was because that's more consistently done across these different models, and also the practice of doing that is longer established. We also didn't investigate non-MPO models. We only looked at MPOs. But I should note that there are other agencies, San Francisco County, for example, or many large transit agencies who operate similar travel demand models. So there could be lessons learned from them as well. But we're not going to get into that today. So when we were reviewing the documentation, we tried to look at what sort of data are needed to run these models, what information do we get from them, what some of the mathematical equations may be, what some of the variables that are used, especially to represent the built environment, and also some operational considerations. So what I'm going to do next is show you the 6 different frameworks that we classified these models into. I'm going to talk about the 4 steps of the model in a trip-based framework, but I also think that these are applicable to tour and activity-based models. A lot of the mathematical structures and variables that are used are the same, whether you're talking about trip generation or tour generation, trip distribution versus destination choice, or trip mode choice versus tour mode choice. And then also I want to distinguish We'll see some boxes here. The light gray indicates that a model stage only uses motorized trips. It only considers motorized travel. The middle gray box represents travel by all modes, and the dark gray represents walking or non-motorized travel. So let's get started. Framework 0 is what we called those models that did not represent non-motorized travel at all. They only consider motorized travel, travel by car or maybe by transit. A number of large MPOs still use this today, spread out all over the country. We found 18 that did so. And it's important to note that they don't use these models, they can't use these models to forecast the demand for pedestrian travel. But they may use other structures, maybe some of the things I mentioned at the beginning of the presentation, to predict travel demand for walking. And a reason why they may not do this in this framework is perhaps because they don't have enough records or survey information to predict and estimate valid walking models. So framework 1 is similar. We have the same 4-step motorized modeling process with a parallel non-motorized process just for trip generation. So what we get are predictions of non-motorized productions and attractions, the number of trips that start here and the number of trips that end here for everywhere in the region. A couple of MPOs do this today, although more of the models in the future the other frameworks that I'll talk about, the MPOs used to use this framework, some of them. Typically, the mathematical equations that are used as cross-classification. Typically, area type is a strong differentiation, which is generally a prediction of urban form, say downtown, urban, suburban, or rural. Pretty crude measure. And then some other variables, usually socioeconomic ones like household size or vehicle ownership. Framework 2 similarly distinguishes only between, Framework 2 only gives you an output of non-motorized productions and attractions. But instead of doing a separate process, it links the two, does trip generation for all modes, and then splits off non-motorized trips immediately afterwards. So again, we only know how many trips start in certain places and how many trips end up in certain places. We don't know actually where those trips are going. 5 large MPOs do this right now, and they use a variety of methods. Some use a basic percentage, say 20% of walking trips are right here. Some others use multiple linear regression, but the more common trend is to use binary logit models, which are a discrete choice modeling structure. Also, interesting to note, in Framework 1, we saw a lot of use of area type as the only way to represent the built environment. Here in Framework 2, we see a lot more of these density, diversity, and design variables, things like intersection density, and Newark uses network connectivity and pedestrian restrictivity, which is basically a measure of what percentage of the roads in a certain zone are pedestrian prohibited, like freeways or major highways. It's also interesting to note that Atlanta uses some accessibility measure, which they calculate as summing all of the activity, which could be people or jobs or some combination thereof, and weighting it by the distance from each zone to all the other zones. So it tries to get at some information that you would know after trip distribution, but at an earlier stage. So that may be one way to include more relevant information to this decision-making framework. So Framework 3 moves that splitting action down one step after trip distribution. And so the difference here is that we now that we know where trips are going, we can include valuable level of service information, things like travel time or trip distance, which are indicative of which travel mode people choose. About 5 MPOs use this as well, including New York City uses their tour-based activity model, uses this framework. We see similar density, diversity, design measures of the built environment, things like sidewalk availability, ease of street crossings, block size, non-motorized path density, and land use mix in Raleigh. And then New York City also uses a similar accessibility measure, although they don't do it for the whole region, they only do it for zones that are within about 3 miles of the considered zone. Framework 4 is probably what you may be most familiar with. It's where walking or a non-motorized mode is explicitly included in the full mode choice model, as opposed to Framework 3, where we saw it was a preliminary mode choice before the full mode choice model. This is actually the framework where it seems most of the MPOs are moving towards, or have already moved. We see 18 large MPOs in this category, including 14 of those that distinguish between walking and biking. The other 4 actually only include a non-motorized choice in the mode choice model. And I'll come back to that in a little bit. Portland does this, as well as Seattle and San Francisco in the West Coast, many others in the West Coast as well. We see some of the same level of service variables being used, typically travel time, but sometimes distance or a generalized cost. We also see some built environment measures being used, but less varied than in Framework 3, where we saw quite a few different kinds of measures of the built environment, like non-motorized path density. We tend not to see that in Framework 3. They tend to be more just intersection density or a couple other mixture variables, things that measure the joint variable of density and diversity, which I'll come back to in a little bit. And finally, we have Framework 5, which takes the output of the mode choice model of Framework 4 and assigns pedestrian trips to the network, predicts where they're going to walk. We didn't find any models that currently do this, although Portland and the San Francisco County models do this for bicycle trips. A couple other regions are in the process of investigating this, but one of the reasons we thought that no models currently do this was that they need detailed and complete information about facilities for pedestrians, sidewalks, off-street paths, maybe even cut-throughs, parks, or other areas in which to predict where people are going to walk. And probably more importantly, we need more information about walking route preferences. We want to know how much people deviate from the shortest path to go to more attractive routes and what sorts of characteristics are attractive about those paths. So this is just a graph showing all of the different frameworks that I mentioned. We have Framework 0 at the top, all motorized travel. Framework 1, where it's a parallel process. 2 and 3, where there's a split before or after trip distribution. Framework 4, where it's within mode choice. And then Framework 5, where we're actually assigning pedestrian trips to the network. And on the next slide, I'll show a map of which MPOs use which framework. And you'll see the colored numbers are the same. So here it is. This just shows the distribution of the regions that we investigated and what pedestrian modeling framework they use. I do want to note, however, that this map is probably changed by now since we did the study last summer. MPOs currently, always evolve their models and develop modeling, pedestrian modeling changes that they're implementing. So I'm sure some of the 0 models have changed right now. So now I'd like to talk a little bit about some operational issues we found while we were reviewing the model documentation. So one thing is walking trips tend to be short in distance and length, but sometimes people walk a long ways for various reasons. Most of the models typically, some of them actually, use a walk trip limit, so prohibiting walk trips from being more than 3 or 5 miles in length. On the other hand, some people may walk more than 3 or 5 miles, and so this could be prohibiting realistic walk trips from occurring in the model output. So what some other regions do is they actually weight longer trips heavier against walking. So you might have a different model coefficient for the first 1.5 miles and then a higher, stronger disincentive for the greater distance. As well, we also saw no consistency in walk speed assumptions. This is really important if we're using travel time as a level of service variable because we have to assume a walking speed to compare to driving time. About half use 2.5 miles an hour, the other half use 3 miles an hour. Both of these considerations are important when we're trying to think whether we want to distinguish between walking and biking or have just a non-motorized mode. Because walking trips are so much shorter than bike trips, coming up with a valid walk trip or non-motorized trip limit can be challenging, as well as assuming a different speed, because walking trips and biking trips used to typically are different speeds as well. So that's a little bit of an issue for those models that only have non-motorized travel. We also saw a variety of land use or mix and diversity variables. Usually these are a mix of jobs and employment, or people or households and jobs and employment. Sometimes they also include measures like intersection density here in Portland. I also wanted to note that although we focused on these modeling frameworks and the different stages of the four-step process, there are other aspects of travel demand modeling that could change in order to make the models more sensitive to pedestrian travel. Things like including more pedestrian relevant built environment measures in auto ownership models might help. Alrighty, now let's switch gears and talk about the survey we conducted. We sent an online survey to all of the lead modelers at these agencies, the 48 agencies. We sent them questionnaires that had two basic questions. What are some of the barriers you see to implementing some changes? And what are some current changes you plan on doing or things that you see you want to accomplish in the future relevant to pedestrian modeling? We got 29 out of the 48 responses, which we were satisfied with a 60% response rate. Our first question asked, why does your model not include non-motorized walking or bicycling trips? By far, the biggest response was that agencies had limited travel survey records available to them. So maybe they did a survey of the whole region, asked a certain number of households, and maybe they didn't have a large enough sample size in order to get enough walking trips in order to estimate a model. So this is a key thing we'll come back to at the end. Another good proportion of respondents said they had limited built environment data. This would be useful towards estimating sensitive models that are sensitive to policy interventions regarding the environment and some of the environmental influences of pedestrian travel. We're blessed here in Portland to have an extensive database, courtesy of Metro, about the environment and the urban form. Limited modeling resources were also a barrier identified by many. This could be time. They didn't have time to spend on developing some of these changes, but more likely it's cost. When they're developing these changes or paying consultants to do so, they have to trade off several options, whether we want to improve how our model represents pedestrians, whether we want to be able to forecast different tolling scenarios, or whether we want to be able to predict ridership of transit facilities that we're thinking about building in the region. These are all trade-offs, and sometimes improved pedestrian representation is below some of these other options. And finally, almost half of respondents said that limited decision-maker interest was a barrier to making some of these changes. Whether that's the leaders of the MPO or the regional transportation decision-makers didn't think that representing pedestrians was an important aspect of their travel models. And that some of this could come down to thoughts about incompatible spatial scales. So travel demand forecasting models typically are using rough, large zones as their unit of analysis, and typically have a street network that's not full, usually maybe arterials or just collectors. And so pedestrian travel sometimes happens within zone because it's shorter distance, and so the models may not be compatible with the spatial scale at which pedestrian travel takes place. We'll see a little bit more about the spatial scale in a second. We also asked what planned modeling changes were underway or planned to occur in the next couple years. Over half said they were engaged in activity-based modeling efforts, either conducting a household travel survey that they would be able to use to estimate an activity-based model, or developing an activity-based model in process. Actually, I think we found that about 8 to 10 of the regions we investigated actually currently use an activity-based or tour-based model. We also saw that 40% are changing the analysis unit, the spatial analysis unit, usually making it smaller. We'll come back to that in a second. A number were also collecting more detailed street environment data. and 17% were actually adding non-motorized travel or walking to their models. So they were moving from framework 0, which just had motorized travel, to one of the other frameworks, or they were changing from just having a non-motorized mode to walking and biking. So here are some examples of some of the ways that MPOs are having smaller analysis units in their models. These are 3 examples from California. So here in Portland, our model has 2,000 transportation analysis zones. In Los Angeles, they're changing their structure to have sub-TAZs, 11,000 of those, which they use to operate their model, all of the model stages there. In San Diego, they're going even further, disaggregating to about the block size. They have 21,000 of those master reference geographic areas in their model, and they use those to generate more accurate travel distance estimates for non-motorized trips that are less than 1.5 miles in length. A similar thing goes on in Sacramento, where their activity-based model uses parcels as the small unit of analysis. And they use the parcel-to-parcel distances for these non-motorized trips. They use that to get a better estimate and adjust the zonal skims, the zone-to-zone skim, travel time estimates for non-motorized trips. As I said, here in Portland, we have excuse me. Here in Portland, we have an extensive database of built environment information, including the extent of sidewalks. And some of these variables could be used to perhaps better estimate pedestrian demand in this kind of framework. And finally, we see opportunity here for pedestrian route choice research, investigating the preferences of where people like to walk. So my colleagues, Jennifer Dill and Joe Broach, estimated Portland's bike route choice model here in Portland, and they collected GPS traces of people biking that were used to predict how willing people are to deviate from the shortest path based on facility characteristics. We could do the same thing for pedestrians, and in fact, our household travel surveys are actually catching up to providing some information that we can use to do that. Typically, household travel surveys use a travel diary that you fill out where you went during the day, what you did, why you went, and what travel mode you took. Well, some regions like San Francisco, a couple regions in Ohio, Jerusalem overseas, are conducting 100% GPS-based travel surveys. So we get GPS traces that are then attributed with trip purpose and other information. We might be able to use these data for estimating pedestrian route choice models. So just before I finish up, we wanted to share some thoughts about the future based on our review of the literature. For those models and regions that are in Framework 0, where they don't model pedestrian travel whatsoever, they might be able to borrow some of the structures or even transfer some of the coefficients, perhaps, from other regions in order to have a better way of doing that. We thought that probably the most valuable way to spend resources is collecting more detailed travel survey information, especially oversampling households that may be likely to walk. If we have more travel survey records, we can perhaps better estimate models, get more statistically significant results, and perhaps capture a wider range of the different characteristics and situations in which people walk. As we've seen, there's a movement towards smaller spatial analysis units, more at the scale of pedestrian travel, as well as collecting more detailed built environment information, especially about street characteristics and things that are relevant to the pedestrian environment. Again, we see a profound need for research on walking route preferences. And then I just want to finish with saying that despite all of these changes to how regional travel demand models represent pedestrians, we still see a need for the models that I mentioned at the beginning, the different ways to forecast pedestrian demand, whether it's separate from the travel modeling framework or something that can take some of the initial outputs, say from a framework 1, where you just had trip generation rates for pedestrians, and maybe using that to then post-process and come up with a different way to estimate walking demand. So I'd like to thank our project team, members here at Portland State University, University of Wisconsin-Milwaukee, and Tool Design Group. I want to thank our project funders, OTREC, and also Metro and Tool Design Group for providing matching funds. Of course, I wanted to thank all of the MPO staff members who contributed to our survey and provided their input and documentation. And then I just want to thank you guys for showing up and listening to information about pedestrians and especially about modeling pedestrians. Here's some more information if you want to take a look, some selected references. Our contact information is there, and I'd be happy to take any questions.
All right, just as a reminder, if you want to ask a question, I've got to give you the microphone.
Yeah, I was wondering if you could explain a little bit about what the advantages or disadvantages are of those different types of frameworks. Is there one that's sort of the best, or?
It's a really good question. I'm reluctant to say one's better than the other. Really, the question was, could you talk about how different the modeling frameworks are, what maybe some positives and negatives of each of them? Is that about right? Yeah. Okay. So really, I'd like to answer the question sort of by framing what information the modelers and people who run these models have at hand. So if you may not have enough information to estimate some of these mode choice models for walking by all the different trip purposes. So for those regions, I'd say it's probably better to do some of this more basic things. But for other ways, the further down you go, the more information you gain from the modeling process. You gain a more detailed estimation of trips. So for example, process 1 and 2, you only get an estimate of how many people are starting walking here and ending up walking here, but you have no way to link them together. But for 3 and 4, you know where they're going from and to, so you have a full trip information. And then with Framework 5, you actually have the route that they might take.
Also related to the frameworks, are there certain volumes of pedestrian or bicycle traffic where they need to move up a framework or start to think about modeling it better?
It's a good question. I know there are several regions who have a high degree of, let's say, walking to work commute share for pedestrian travel, who still are in Framework 0. So they could probably do a better job of, if they had the resources available, collecting more travel survey information to move their framework from 0 to 1 or to 4, perhaps. Yes?
So I'm still becoming sort of familiar with the capability of these models, and I'm wondering, do MPOs or can MPOs use these to estimate the impacts on mode choice of specific investments? So, like, for example, can they say, if we install this freeway, it will decrease walking by X%?
Probably. If they've included walking all the way, say, to the mode choice framework, we'll say your example of the freeway, that would probably decrease travel time for driving. And so that would, when you're deciding between the different modes in the mode choice model, it'll make driving more attractive than walking, for example. So yes, depending on what framework you're in, it might make a difference. But there are some other ways where you can, maybe if that is an input to the trip generation or the auto ownership framework, then that could change even if you don't have a Framework 4 model. Let's say. Yeah.
This sort of gets back to that earlier question about if you did any sort of secondary analysis or maybe a regression analysis about the types of places that use Level 4 frameworks, if it was based on the resources of the MPO or whether they generally had higher mode splits of non-motorized transportation based on activity surveys, or whether it was something about sort of the political trends or atmospheres, or just did you do any sort of regression to say that this type of MPO is more likely to use this type of framework?
No, we didn't. But I agree that that could be a valuable method of analysis for the future.
So a question from one of our web viewers about the respondents that perceived limited decision maker interest. what factors were you able to find out any factors that motivated increased interest on pedestrians from decision makers?
We weren't able to get any information about that in our study. I might speculate that I guess increased attention at the regional level about biking and walking issues might, or advocacy, pushing regional leaders to invest in some of these modeling changes might have had an impact, but that's just speculation at this point.
When you're modeling pedestrian and bicycle non-motorized behavior, are you looking at the volume of non-motorized traffic you'd get in prime weather, like the best time of the year, like a peak, or are you looking at more of a median or a mean traffic level for non-motorized?
What these models tend to do are just to estimate an average workday over the course of a year. So they don't typically distinguish between seasons or day of the week, or even sometimes time of day, unless you get into some of the assignment models do distinguish by time of day. But generally, it's just an average work day over the course of the year.
Would you explain the difference between the framework 2 and 3? Because I think to do a framework 2, according to the framework 2, was the mode choice or mode choice of the bicycle or pedestrian should be performed, right? Or yeah, would you explain the difference between 2 and 3?
Sure. So the major difference between 2 and 3 is that in 2, all you know, all the model knows is the estimated number of trips generated in a certain area that start their trip in a certain place. With Framework 3, when you're doing the decision whether it's non-motorized travel or motorized travel, what percentage of those trips are, the trip distribution step has actually linked those origins and destinations together into trips, those productions and tractions into trips. So you're able to use information about travel distance where you couldn't have used that in a Framework 2 model. Does that sort of get at your question?
You talked a little bit about the need for a more detailed a true pedestrian network. And so I just wanted to make a plug for some work that the City of Portland did a couple years ago, and that's been carried out by a wonderful group here at VSU, the GIS Jam, and I know Katie Urey's here from that, and Liz J worked on this also. But to actually find a way to take our street network and make a pedestrian network out of it, with the idea that pedestrians typically, especially on arterial streets, are going to be traveling either on one side of the street or the other, and that the crosswalks that are available to them are an important link. And what we hoped to do from that was then to be able to do exactly what you were asking about predicting what improvements would actually make it better for travel, because we'd have a real network, and if you dropped in a new crosswalk, it would improve the network connectivity.
You make a really good point. Designing a pedestrian network is much more complicated than, in some ways, than a street network for cars.
Can you talk a little bit about the level of detail that the participants as they give their trip generation surveys are, and how is the rate of error calculated, if there's any?
It's a good question. Typically, when households heads or respondents are filling out the survey, they typically do it, I believe, they report every travel that they made during the day, and they could either take it with them while they're traveling and record it as they go, or they might sit down afterwards and try to remember back to what they did during the day. I don't have a good idea of an error rate for that, but there are definitely a few studies out there that have looked at that for sure. And that definitely impacts some of these models.
Do you have a specific example or a set of examples of where some of these frameworks were actually used to inform investment, perhaps a pedestrian bridge or something like that across the country? I don't know if you were able to do that during your research, but just an example or two.
I don't have a great example of that. The best I think I could come up with is what I shared at the beginning, where they were used to make the models more sensitive to land use scenarios and other sort of broader transportation alternatives. I'm sure that several of the regions have tried to investigate what would happen if you built a pedestrian bridge, say over Interstate 5 next to the south waterfront or something like that. But one of the issues with these regional travel forecasting frameworks is that the pedestrian, or all of the estimation that they get, is pretty crude, I'd say. So you may find it more useful to have some of these other types of pedestrian planning tools for individual projects like that.
Okay, before we thank Patrick for his talk today, the speaker next week is our OTREC visiting scholar. We have Gene Hawkins. He's from Texas A&M University. He's an expert on the manual and uniform traffic control devices, and he's going to be talking about the future of where that manual is going in terms of its flexibility and use for the engineering community. So I look forward to that, and thank you, Patrick, for your interesting talk today.